Welcome back, Pre-Calc. Our objective today is going to be to apply function transformations. Again, a lot of this should look like review from Algebra 2, and of course, pause on your screen, you know what to do from here. All right, just want to make sure you also have a couple other things with you that were not on the checklist. Can you make sure that you have this sheet with all the parent functions filled in, as well as what we filled in class with what the different transformations look like algebraically? Force pause on your screen. Can you please copy example 1 in your notes and then go ahead and graph for me f of x, the parent function y equals absolute value of x. So we are back. I've got the parent function graphed. Now let's go ahead and graph together g of x, and that plus 2 is going to shift this blue function which way? This is going to go up 2, so go ahead and write that, and then let's plot what we have here. So take that original blue function, shift it up 2, and that is going to be g of x. Okay, now our next function, h of x, we've got 2 transformations there. What does the negative 2 do in this case? This is going to be right 2. Remember that inside's always opposite. And the reason for that is because our functions are always y equals something, never x equals. And so we have to think, okay, what do I have to do to get x by itself? In this case, if I were to zone in on the inside piece there, I would need to add 2 to get x by itself. So I want to go to the right 2 and then down 1, right? Let's graph that. So now my minimum should be at 2, negative 1. All right, that last one, how many transformations does j of x have? It's got 2. The negative is on the outside, so is this going to be a vertical reflection or horizontal? This will be vertical or over the x-axis, however you would like to think of it, but I'm going to stick with vertical reflection. And then the plus 3 is going to do what? This is going to shift left 3. It's on the inside, so I have to think, hey, what do I need to do on the inside to get x by itself? And that would be to subtract 3. All right, go ahead and graph that for me. So we should have something like this for j of x. Okay, now go ahead and copy f of x, the piecewise function here in your notes, and then let's go ahead and try to graph this one together. Okay, we are back. So that top piece, notice it is valid for x's less than 0. So for this piece, just kind of thinking ahead, do you want open circle or closed circle here? This is going to be open circle because it's strictly less than 2. So let's go ahead and graph, thinking about our parent functions and our transformations. Let's go ahead and graph that, and then we'll erase the pieces that we don't need, okay? So we've got our parent function y equals x squared, but this has been shifted which way? This has been shifted up 1, so it will look something like this. All right, not the prettiest, but we've got that covered there. And then let's go ahead and draw our guide at x equals 2, right? Because that's where I could have my possible discontinuity. So I'm going to draw my guide here. Now, do you want to erase everything to the left of 2 or everything to the right of 2? We're going to erase everything to the right of 2 because we want x's. This is only valid for x's strictly less than 2. And again, we said open circle at 2, and that will be the point 2, 5, right? If I plug in 2 there, I get 5 for y. Okay, let's try the bottom piece now. So I've got square root of x. So think about the parent function square root of x, and then this has been shifted which way? To the right 2. Again, inside's opposite. I would need to add 2 if I wanted to just solve for x on the inside. So let's go ahead and graph that. So notice that this function already starts at x equals 2. The domain is actually x is greater than or equal to 2 because we don't want a negative number inside that square root. How about open circle or closed circle here? Closed circle. All right, some questions for you. Does this pass the vertical line test? Yeah, always double check your piecewise functions. What about continuous or discontinuous? This is discontinuous at x equals 2. I would need to pick up my pencil there to draw this all kind of in 1. And then what kind of discontinuity, removable or non? This is non-removable. It's a jump. Like there's not one point I can move or add to make this nice and continuous. So we've got a non-removable discontinuity here at x equals 2. And force a pause on your screen. Can you please try this one on your own? Hit continue when you're ready to see the answer. All right, here's what we should have gotten. Be very mindful of which one has the open circle and which one has the closed circle. Make sure yours passes the vertical line test always. And again, a couple questions. Continuous or discontinuous at x equals 1? Discontinuous, I definitely have to pick up my pencil there. And removable or non-removable kind of discontinuity. This is non-removable. Again, we can always check analytically. If you plug in 1 for x to both the top and bottom pieces, you get different values. So if I plug in 1 for x here, I get 2 as my output. If I do the same thing to the bottom piece, I get -3 as my output. And since those are different, again, that's what creates that jump, those different y values. First pause on your screen, and I just kind of want you to sketch what you think square root of the quantity x minus 3 looks like. And then when you're ready to talk about it, go ahead and hit continue, but get a sketch on your paper first. All right, so on the screen I've got a couple options. I've graphed the parent function, just y equals square root of x, and then we know that we need a horizontal reflection, and we know we need to move to the right 3. The question is, what order? Does the order even matter? So with kind of that pinkish purplish graph, I flipped over the y-axis first, and then I shifted to the right 3. For the blue, I shifted to the right 3, and then I flipped over the y-axis. And you can see order is going to matter here, right? So the question, and maybe you had different ones as well, but order certainly matters. The question is, which one is the right one? Remember that when we're working with inside pieces, we need to think, okay, what do I need to do to get x by itself? In this case, if I wanted to solve for x, I would add 3, and then I would divide by -1. So the correct graph here is the blue one. We want to shift right 3 first, and then go ahead and do the reflection. Let's verify on Desmos. Okay, so I've got just the parent function graphed here first, y equals square root of x. Here is the graph we were asked to sketch, right? Looks like that blue one that I had on the screen earlier. Now the question is, what about that pink one? What would that be? Remember, for that one, we did horizontal reflection first, and then we shifted to the right 3. So what about something like that, right? So now if I take this inside piece and I set it equal to 0, for example, if I wanted to get x by itself, now I would divide by -1 first and then add 3. All right, I'm going to force pause on your screen. Can you please copy the graph? You don't need to copy A through G yet. Just copy the graph in your notes. I would just plot these 4 points and then connect them linearly. All right, let's go ahead and do A together. So what would that -1 do to the original function? We would shift down 1, right? So what I'm going to do is I'm going to take my 4 points, I'm going to keep the x's the same, but the y's are I'm going to subtract 1, right? So I take my old f of x and I subtract 1. So 4 minus 1 is 3, but I'm keeping -2 as my x. This time, instead of the point 0, 3, I will have the point 0, 2. Instead of the point 1, 0, I'll have the point 1, -1. And instead of the point 3, -1, I'll have the point 3, -2. And then we can connect linearly. So it should look something like that. Okay, what about B? Which way do we shift here? This is going to be left 1. Again, inside's opposite, so think about setting this equal to 0, and to get x by itself, I would need to subtract 1, okay? So before I had the point f of, I could really think of this as f of -2 equals 4, right? So now, to get back to that 4, what I would plug in for x here would actually be -3, because I would want this whole piece to be -2 in order to get this statement again, right? So we're going to shift left 1. So instead of -2, 4, I'm going to have -3, 4. Instead of 0, 3, I'll have -1, 3. Instead of 1, 0, I'll have 0, 0. And instead of 3, -1, I'll have 2, -1. And then let's connect. Good, so we should have something like that. For the remaining 5, I would like for you to just write C, D, E, F, and G, and the function notation there, and then you don't need to graph, but just put in words what the transformations are. Go ahead and hit continue when you're ready to see the answers. All right, I've got the answers on the screen, so you can check yourself there. Do go ahead and correct anything with your second colored pen or pencil, and summarize with one sentence at the end of your notes, and I will see you all next time.